Hi there, my name is Richard Mallion, so thank you for watching this session. This session is going to be about utilising Swift with the Jamf Pro APIs. Okay, so it's not really a deep dive into Swift, it's more about how you can use Swift to access the Jamf Pro APIs and get access to the data, retrieve data and post data back to your Jamf Pro instance. There'll be a few slides where we kind of do a slightly deeper dive just to kind of clarify things, but in general, hopefully it'll be pretty straightforward. Okay. So to start off with, Jamf have got some really good documentation on their APIs. They've got a really good developer website now, which has been revamped recently. So there's a lot of good material there. And there's lots of good examples in languages like Python and kind of shell scripts, etc. But not much so in Swift, hence the reason for doing this session. You can also access documentation from your own Jamf Pro instance. If you just go to your URL/API, you get access to the documentation, and there's also you can access the APIs through a web interface just to kind of get a handle about how they work and what sort of data you can expect from them. So Jamf has two types of APIs with Jamf Pro. We've got the classic API, which has been around since day one. So this has got a lot of the legacy kind of functionality built into it. And there's also a new, more modern approach, which is the Jamf Pro APIs, which work slightly subtly different to the classic ones. So we'll look at both and the differences on how they work. So we'll start with the classic one, and then later on we'll switch over to some examples with the Jamf Pro API. So to start off with, the classic API, there are some limitations. So if you're getting data, so you're querying your Jamf Pro server via the APIs, you can get the data back in an XML format and JSON format, but you are limited to only posting data back to Jamf Pro in XML. So that's one of the limitations. The endpoint you're going to hit is your Jamf Pro instance URL /JSS resource. So this is going to be our base URL. And from this, we can then expand on it to hit the specific endpoints for the classic API. So to start off with, you need to authenticate to Jamf Pro to be able to use the APIs. So you can use the standard built-in users and groups to create a specific API account. Or if your Jamf Pro server is connected to maybe like a directory server like Azure or Okta, you could use one of those accounts as well. So you can create an account specifically for the API access, but importantly, you need to make sure that you match the permissions to what you want to achieve with the API endpoint. So it can be quite tempting to grant this account full admin access, but don't do that. Just give the account exactly what you need to perform your task. So no more, no less than what's required. Jamf have got some documentation on the classic API about what the minimum required privileges are. So you can use that to kind of get an idea of what you would need to set up. But basically what we're talking about is if you go to Jamf Pro, you can create a standard user account for this, or kind of group permissions. And you can grant access to kind of various aspects of Jamf Pro. So for instance, you've got the objects access. So this is where you can grant access to things like computer records, mobile device records. And it's quite granular. You can grant access based on whether you want to create these objects, delete them, read from them, or even update them. You can also get access to the Jamf Pro settings. So again, you can either read the settings or grant update access. And I guess more interestingly, you've got the actions. So these are a lot of the MDM commands. So you can, again, grant that API account access to specific MDM commands or actions you want to perform. So again, only grant what you need. Don't grant the wipe option if you're not going to use that, okay, for security reasons. So there is a one-to-one mapping. So we are going to be using HTTP requests to get access to the APIs. So we can use the standard post, get, put, and delete, and they do match to the Jamf permissions. So for instance, if you're going to create an object, we use post. To read something, use get. Update will be put, and delete's delete. Okay, so the documentation should make it pretty clear about what permissions you need for a specific API. So to get access, step one, you need to create some credentials. Okay, so you created your user account, and then to use those account details, we need to create a base64 encoded version of your username and password separated by a colon. So we can build up a string very straightforward in Swift. We can concatenate our username, our passcode, and that colon. Okay, but then we need to convert that to base 64. So then we can use that within the API. So to do that, we can take our string, and it's a two-step process. We're going to chain a couple of commands together. So on that string, we can first of all convert it to a data object. So we're going to come across these more as we go through the APIs. But basically, a data object is an object that can contain, basically, it's a buffer of bytes. So you can treat it like a bucket of bytes or bits of information. So it's got no specific type, but it's just information. So we're going to convert our string, first of all, to a data object. And then from that, we're going to basically ask it to be encoded as base 64. Once we've got that, we can then pass that to the APIs to allow the authentication. Now, I did say this wasn't a specific deep dive into Swift, but it's probably worth talking about something very specific, which is optionals. So we are going to use this a lot within the code examples. And if you've never seen optionals before, it can get a bit confusing. So just a quick 101 on optionals. So with optionals, these are basically, it's a mechanism in Swift to allow you to either have a variable that either has a value or has no value. Okay, so it basically allows us to handle the absence of a value. And this may be quite common. You may have a situation where you've called an API and no data's come back. And we need to know that there's an absence of a value. Okay, so these options, we either have a valid value, or if there's no value, then we use nil, NIL, which represents no value. And we create optionals by using the question mark. So the question mark in Swift is used a lot for optionals. And you normally use this in relation to the type of data you want to utilize. So as an example, we have an integer. So we've got this int type. So an int type must store a real integer. Okay, so when you come to use it, there must be a valid integer in there. It can't have no value. To make it an optional, you put a question mark after it, so it becomes an optional integer. And this optional integer can then either have a value, which would be a valid integer, or it can have no value, which is represented by nil. Now, the way I like to look at optionals is it's like a box. So if you treat the optional like a box, and inside the box, there may be a value, which is the item you want. Okay, so you've got this box, and then to get to the value, you have to unwrap it. And if you unwrap it, you can then retrieve the actual value that you're interested in. If the box is empty, then it's nil, and there's no value. Okay, that's how I like to visualize them. Okay, so if you have an optional, you need to unwrap it, and there's a couple ways we can do this. One approach is what's called force unwrapping. Now, you're slightly careful here. This is slightly dangerous because with force unwrapping, you're basically doing a brute force unwrap. You're just unwrapping the optional regardless. You're not going to check it, and you're going to just try and retrieve the value. Now, if you try to force unwrap an optional that has no value, you will get a runtime error. Okay, so which is what we don't want. Okay, so you only use this in a situation where you're 100% sure there's going to be a value. And there are some situations within your code that you can guarantee there's going to be a value at that point in time. So to unwrap an optional forcefully, we can use the exclamation mark. So if you append an optional with an exclamation mark, that will force unwrap it. So in the last line, we've got an example where we're unwrapping the optional status code variable with the exclamation mark, and that's going to unwrap it and put the value into status code from which we can then use it. Okay, so just remember this is slightly dangerous because if optional status code was empty with nil, then we get a runtime error. So if you're not sure it's empty, we can do this slightly more safely with something called optional binding. So optional binding is a mechanism in Swift where Apple, with one line of code, will do a number of tasks. So in this case, it's going to first of all check whether the optional is empty. So is it nil? If it's nil, then nothing else will happen. It will bypass this block of code and carry on, assuming there's nothing to see. If the optional has a value, it will automatically unwrap it for you and then assign that value to a constant you've defined, basically. So that if-let statement, that one line is doing all that work. So in this situation, it's going to look at optional status code. If it's empty, then this statement fails and it bypasses that block of code that would have handled the result. If, however, there is a value, it will automatically unwrap it, apply that value or assign it to status code, and then your if statement will then process that value and do whatever you need to do. Okay, so you're going to see a lot of this if-let statement throughout the sample codes. So the first example we're going to look at with the classic API is just getting a list of computers, a very simple list of what computers are in your inventory. So step one is we need our base 64 for name password. So we've seen this already. So we're going to create our base 64. Then step two, we need to create a URL of the endpoint of the API we want to hit. So we already said that the classic API endpoint is your Jamf URL appended by JSS resource. And then for this particular API, we're going to append it with computers. So that's the computer endpoint where we can grab computer records. So we create a string that's going to have this complete URL, and then we're going to convert it to a URL type. So Swift has a specific URL type. So we're going to use that, pass in that string we've created, and we get a URL back that we can then use going forward with the APIs. So notice that we've got an exclamation mark after this. So when you convert a string to URL, it will do it as an optional, because there may be a situation where it can't convert it to a URL. That string may be badly formatted, may not be a correct URL, can't be converted. So it needs the ability to fail. So in this situation, I'm using the exclamation mark because I know that URL will pass and it'll work. But if you're unsure, you could do the if-let version just to make it a bit more safe. So at this point, we now got the URL. Step three is we need to create what's called a URLRequest. So this is a class within Swift, and basically it will store the URL, and it also encapsulates some information about how to access that URL. So for instance, we can specify the HTTP method we want to use. So is it a get or a post? Is it a put or delete? We can also specify headers. So one of the headers we're going to specify will be the authentication, so the authorization we're going to be using for that API. And there's also two other specific headers we can use, and we will use this as we go through. There's one called accepts. This would specify what sort of data we want back from the server. And we've got a choice of XML or JSON. And there's also one called content type. So content type specifies the sort of data we want to upload to the server. Okay, so maybe you've got like a payload you want to upload. So this can be JSON or XML, but with the classic API, we are limited just to XML. So if you have no payload to upload, you don't need content type. And if not downloading anything, you won't need the accept. So you use these based on what you're trying to achieve. And so we've got some examples of both as we go through. So to create the request, we're going to create a URL request, and we're going to pass in the URL we created. So that creates the request. And then we're going to customize it, just set the method, the body and the methods and the headers, etc. So there's a property called HTTP methods. And here we specify whether we're doing a get, a post, a put or delete. So in this case, we're going to do a get. We're going to get some information from the Jamf Pro instance. And then one of the headers we're going to set is the authorization header. So the authorization header is where we pass in the base 64 of our name and password. So we can use the basic keyword, and then we're going to append to that the base 64. So that's going to set the authentication. Okay. And because we're going to receive something, I'm going to specify what format I want that back as. So you could use XML, but in this example, I'm going to be using JSON because in some ways JSON is slightly easier to handle than the XML and Swift, but we could have specified XML if we required that. So that's our request now set up. The fourth step is to actually now go and action that request, go and execute it. So for that, we've got a class called URLSession. Okay, so URLSession is a bunch of classes that will act on the request, and it will let you perform various tasks. And there's three main tasks. We have a data task, which will allow us to pull down data from our web service. We've got an upload task, which allows you to upload files to an endpoint. And we've got a download task, where we can download items. So we take our requests, and then we're going to create a session with that request, and then get it to form that task, and hopefully we get something back from it when it's completed. So to create our session, we're going to create a URL session. Now, there's a couple of ways we can create this. there's quite a lot of configuration with this session, more than we can cover in this half-an-hour session. So with URLSession, one of the things you get is a singleton version of that class pre-set up, and this is fine if you want to do use the basic default settings. So if you do URLSession.shared, you're going to get a session already created for you, and then we're going to append to it the type of task we want to perform. So in this case, it's going to be the data task. So we're going to create a session with data task, and we pass the data task the request. If you remember, which had the URL, it had the authentication, and it had the the method we're going to be using. Okay. Now, when we execute this task, it will run asynchronously. So we've got no idea when it's going to complete. Okay, so it could be the task takes a second, or it could take a couple of minutes based on what you're doing. Network speeds, what the server is doing, can have a big impact. So we don't want to hold up the application here. We want this to run in the background, and then to perform a task when it is completed that session. So what we're going to do is we're going to pass it what's called a closure. So a closure is a block of code which is encapsulated with curly brackets, and this task session, will take that closure and hold on to it. And any code within this session will then be executed once that task has been completed, whether it's a few seconds down the line or a few minutes. So we don't have to wait around. We can just pass it the code, and we know that at some point in the future, the code will be executed to handle the results back from that task. Okay. Now you are passing 3 items, which is the data, the response, and the error. So we'll look at it in a second. So we have this closure, which is called a completion handler. So this is basically it's basically a block of code that's going to be handled when the task is completed. Now, to execute this task, to actually kick it off, we take the task and we call resume on it. So resume will start that task. Okay, and now it's going to go off to that specific URL and hopefully get some data back. Now, it must be said that the order here now is slightly weird to look at, because the first line sets up the task, the bottom line then starts it off, and then the middle piece is what happens when it's completed. So it can be a bit awkward to read sometimes, especially if you've got multiple versions of this in your application. But just remember, the first line is your definition, the last line starts it off, and then we've got the block of code in the middle. Now, we are past 3 items. So we are past a data object. So the data object is like this bucket of bytes. So it holds all the data that came back. The data object is an optional, so we have to unwrap it because we may not get any data back. The response is the HTTP headers and status codes we get back from that web interface, that web server. Okay, so we can use this, for instance, to check that we get the correct status code that we're expecting, to make sure the server didn't produce any errors. Okay, and then we have an error object, which gives us a more underlying failure or list of errors that may have occurred for that particular framework. And again, the error is also an optional. Okay, so what we really want to do basically is have nil for the error. We don't want any errors. We can check the response code to make sure we get the appropriate response code back from the server to indicate the API is executed, and hopefully we'll get a data object back with the data we're interested in. So we see how this plays out now. This is a list of response codes for the classic API. So for instance, for a get, you're looking for 200. Anything that, for instance, creates or updates an object will be a 201 that you want back. And then the rest of them are errors. So for instance, a 401 is authentication error. 403 is invalid permissions. So it's worth interrogating the status code, especially if you're getting errors back. Hopefully give you a clue about why it failed. So if we take our session now, we're going to now populate that closure with the code to handle the results back. So the first thing we want to do is want to unwrap the error to make sure nothing bad has gone wrong. So we're going to do our if-let syntax, and we're going to unwrap it. So if the error is nil, it's empty, we know it hasn't failed. Okay, so the if statement will just fall through. Obviously, if there is an error, we unwrap it, and we can handle that error within that if statement. Assuming there's no error, we then handle the response. Now, there's a little bit of work here we've got to do. So we have to convert the response we get back to a type called HTTP URL response. So this is the type that will then give us access to the status code. So we do that by using the as command. So as will let you convert one type of data to something else. So convert this, make this as that. But we're going to make it an optional version. So we're going to do as question mark, which basically means if it fails to convert it, we will get nil back. So we've got a nice, easy way of knowing it's failed. But assuming it does convert it, we can then access the status code property, and then we're going to check for our specific status code. So in this case, we want to check if we got a value other than 200. So 200 is successful. Anything else will indicate a failure. So if it's not 200, we know it's failed. So again, within this status, this if statement, we can handle the error. But assuming it is 200, it'll fall through, and then we can handle the data. So the last thing we're going to do is unwrap the data object. And at this point, it's not that usable as data object. It is literally a buffer of bytes, okay? But one of the first things I do is I like to just check what I got back from the server, just to print it out. So we can convert this to a string, and we can then print it out to see what we got back. So we can take that data object, convert it to a string, and print it out, okay? And what you should get back is something like this, JSON. So this is the JSON we get back for the list of computers. So literally we have like a dictionary with computer keywords, which then has a value of an array, and each computer in that array has an ID and a name. So it's very, very straightforward. There's only really 3 items in here. You've got the computer key, and then you've got the ID and name for every item. Okay. So this is the JSON we got back. So the final step is to convert this into something a bit more usable. So ideally, to convert this into something that Swift can handle natively. Now, there are many ways you can do this, but one approach I like to take is to create a Swift model that matches that data in the JSON data model we're getting back. Okay, so we can create a Swift structure and then just convert that JSON directly to that Swift structure we've created. And then from there, we can access the data using the native Swift commands, etc. So to do this, we can use structures. So a structure in Swift is a type that does a number of things, but the main 2 tasks is it can store values. So it does this by using properties, and basically properties are just variables or constants. And it can also perform tasks, and it will perform tasks by adding functions. But in this example, we only want to store the values. So all we're going to do is we're going to create the properties to match what's in the JSON we get back. So on the right-hand side, if you look, if we break it down, the native JSON, we've got the computer's dictionary. So we want to map to that. And then we have an array we want to map to. And that array has 2 properties, an ID and a name. So on the left-hand side, the top structure is just literally going to map to that first keyword, that computer's. So we're going to create a structure by using struct keywords. You give it an arbitrary name, so I'm going to call it all computers. And notice the colon codable after this. Codable will allow this structure to be, will allow it basically to allow that type to decode or encode on the fly. So by making it codable, we can then take that JSON and convert it immediately to this new structure that we're using. Okay. So the first structure is for that keyword, computers, and then the second structure is going to handle the specific computer. So it's going to be an array, for instance. So it's going to have an ID and it's going to have a name. So the ID is going to be an integer, and the name is going to be the name of the computer, i.e. the string. Okay. So now we've got a one-to-one mapping of those 2 structures that match that JSON. Okay. Now, one thing to be aware of, the constants you create must match the names of the attributes in the JSON, and they must all exist. So by default, if I've got 10 attributes in the JSON, I need to recreate all 10 attributes in my model. In this example, I've only got 3 attributes, so I've recreated them all. So if it's a mismatch, so if the names don't match or you haven't covered all the attributes, when you try to encode that JSON into this type, it will fail. Okay. So we build our structures, and then we can convert the data. So back to our session, so we've unwrapped the data object, and then we can then create a decoder. Now, Apple supply two main decoders. There's one for JSON, and there's one for property lists. So we're going to create a JSON decoder, and then we're going to basically ask that decoder to decode something, and we pass to it the data object and also the type we want to convert to. So in this case, we're going to take our data object and convert it to the all computers structure we created. Now notice the try keyword. So this decoding can fail because it might be the JSON we get back is invalid. So if it fails, it's going to throw an error. So if anything throws an error, we have to put try in front of it because you want to try. It's not guaranteed to work. And we can make it an optional try. So in this case, if it does fail, we get nil back. So again, we're using this kind of nil operator within the optional to indicate no value. So notice the if let statement. So basically, it's going to decode data. If it fails it, we get nil back. So this statement will fail. If it works, we get the data encoded back into the computer's attribute, constant, and then we can use that in our data in our application to handle that data. Okay, and this is going to be pretty much boilerplate code. So going forward, we're going to reuse this code over and over again. It's pretty much the same as we go forward. So that's a fairly simple one. Just to ramp it up a bit, the next example is where we're going to retrieve a specific computer. Okay, so we're going to do this by specifying an ID for a computer. But in this example, we're going to get a lot more information back. Okay, so it's still the same endpoint, so /computers, but we're also going to now append to it the ID of the computer we want to get the information back on. So step one would be to create the URL. So it's as we did before. So we've got our JSS URL, JSS resource computers, but this time we appended ID and we named the ID. So whatever computer is ID 28, and we convert that to URL. So that's step one. And when we execute this is going to be slightly different to the last example. We're going to get back a lot of information, lots of it. And chances are we won't want all this information. So we're going to get back by default every category of information for that specific computer. So we've got like general, hardware, software, and each of these categories has quite a few attributes. So in total, there might be over 100 attributes that are going to come back for this one call. Okay, and chances are we don't want all this information. We only want a subset. Now, one approach, which is a pretty bad approach, is we could create a structure that covers every attribute in that JSON. So if we've got 100 attributes, we could create one monolithic structure that has every attribute built into it. Okay, which will be painful to build and also be slightly unreliable, because if that JSON ever changes, so Jamf comes along and adds a new attribute or removes one away, it's going to break because we won't have that one-to-one mapping. So creating these large monolithic structures is slightly time consuming and prone to error. But we've got a couple of approaches. So one approach is we can use the API to reduce the categories we get back. So rather than having all the categories, we can modify the URL with a subset or append the subset keywords. And after that, we can specify which categories. So in this case, we're going to specify what the general, the location, and the hardware category. So that's going to reduce the number of categories that come back. But again, though, each category is still going to have quite a few attributes. And we may not want all these. We may only want still a subset of these. Okay. So how do we continue with this? Well, the first step is to create a structure of the attributes we're interested in. So we're going to recreate that structure. So if you start with the top left, we're going to have a structure to hold the computer. And then that's going to then hold, then we're going to have a second structure below that, which is going to hold the categories. And then on the right-hand side, we have structures to hold all the attributes we're interested in for each category. So for instance, for hardware, we've got model and OS version. So this is naming the specific attributes we're interested in. But at this point, this is going to fail because we haven't completely matched all the attributes within the JSON. So to get around this, we can add what's called coding keys. So coding keys basically allow us to name the specific attributes or properties we're interested in from that JSON. So this is basically like an authoritative list. So we're going to name those properties, and then that's all we're going to get back. Anything else, any extra attributes will be ignored in the JSON. Okay, we're just going to name the ones we're interested in, and as long as they exist, that's what's going to come back. So as an example, if you take our hardware structure, we've created the two constants to store the values, And we then add what's called an enum. So an enum, in this case, will hold the list of the properties we're interested in from that JSON. So we use a case command to match specific properties we're interested in. So as an example, the first one is model. So we've got case model. So that's the first attribute. The second example is slightly different, because by default, your constants you're going to create have to match the names of the attributes inside the JSON feeds. But it might be you don't want to use the same naming convention. You might want to use slightly different naming convention inside your code. So what you can do is you can do a conversion. So the second case statement is just specifying that OS_version is what we're going to look for in the JSON, but we're going to store it in OS version within the structure. Okay, so we're just basically doing like just specifying which one we want. Okay, so long as model and OS_version exists, that will now do that JSON conversion successfully. So we end up basically adding those coding keys to all our three category structures. We've got a set for general, a set for hardware, and a set for location. And then our session is as before, and our request is as before. So we're going to create a request with the URL we created. We can use these. We can set the HTTP method to get. We can set the authorization header to our basic base64, and we're going to specify JSON as the data type that we want returned from Jamf. We then create our session. We pass in the closure. At the end, we're going to resume it, which is going to start that particular session. And then within inside the closure, when it's completed, as before, we're going to handle the error to check if there's an error. We're going to check the response code back. So if it's not 200, it's failed. So we're going to handle the error there. And then finally, if we get past those two steps, we're then going to unwrap the data object, create our JSON decoder, and then we're going to decode it to that new type we created. So you can see this is kind of boilerplate code. It's going to be repeated over and over again for most of the examples. So that's how you can handle quite complex data sets and kind of ignore a lot of it and just kind of capture what you're interested in. The next example is a post example, and the example I've picked is sending a mobile device command to a mobile device in Jamf. So the first example is going to be sending the enable Bluetooth command. So the endpoint we're going to hit is mobile device command /command. So as before, we're going to create a URL, and with this one, we're only going to send it to one device. So we're going to create a URL that's going to have at the end the name of the MDM command we want to send. So in this case, it's the settings enable Bluetooth command. And then we also append the ID and the ID of the device we want to send that to. So in this case, it's ID4. And if you want to send another command, all you do is you take out settings enable Bluetooth and switch out with the other command you want to send. So the text in white are some example commands you can send to a device. So we create a URL. We can convert that to a URL as before. We're going to create a URL request. So we create the request. This time the method is going to be post. We set the authorization header. We don't need content type or the accept headers this time because we're not going to get any data back. We're literally going to send the command and check the status code back to make sure it looked like it was accepted. So we've got a simpler request this time. And then we create the session. And as before, we're going to handle the error. We're going to look for the response code. So in this example, 201 will be the response code we want to get back. So if it's not 201, we handle the error. Otherwise, if you get past that, we know as far as the Jamf Pro server is concerned, that command has been sent. Okay, so a very simple MDM command. Now, some are slightly more complicated. So next example is another MDM command, but this time using the lost mode command. So the lost command has a couple of steps. So with lost mode, you also need to send the lost mode command, but you have some options to set the text you want to display on the lock screen, and also whether you want to play that really annoying kind of submarine ping sound you get. So there's a bit more we need to set up with this. So it's exactly the same endpoint. So I'm going to basically use a mobile device command endpoint, and I'm specifying enable lost mode. But notice this time I'm not specifying the ID. I'm going to do that later on, along with the other information about the message and whether I'm going to play the sound. So I've got a slightly simpler URL, which I'm going to create. I'm going to create a request, and I'm going to set the method to post. I'm going to set the authorization header to our base64. And with this example, we are going to upload a payload. So with the classic APIs, you can only upload XML. So I'm setting the content type to XML, so just to kind of make things a bit clean, etc. Okay. Now I need to upload some XML to specify like the message, whether we play the sound for the loss mode, and the ID of the device you want to hit on that API. So in white we have the XML in kind of human readable form. This is what we want to create. So you can see, for instance, there's a attribute in there for loss mode message. There's one for loss mode with sound, and also we've got the ID for the ID of the device. So that needs to be created. So we can just create that as one string. Okay, so we've got one string, and we can substitute into that, the message or the Boolean for true or false for the sound, and also the ID. Okay, and then once we create that XML, we can then encode it as a data object, and we pass it to the httpBody on our request. So now when the request gets executed, it's going to upload that XML to the Jamf Pro instance. So then we create our session as normal, we resume it to execute it. And again, there's no data coming back, but we can check for the error. And again, we're going to check for 201 status code. So long as we get 201 back, we know where far as Jamf is concerned, it's gone through okay. Okay. So that's an example of something more complicated post. The final example is a put. So here we're going to use put to modify something. So in this case, we're going to modify a static mobile group. So the endpoint for this is mobile device groups / name. So step one is we create the URL, and we append to the URL the name of the static group we want to modify. So in this case, it's going to be the VIPs static group. So we can create the URLRequest as normal. So we're going to set the method to post of the authorization, and we are uploading a payload. So we're going to set the content type to XML, because that's what we can use. And then we're going to need to create the XML body. So in this case, the XML in white is what we want to recreate. And you notice we've got the mobile device additions kind of attribute. So this is what we're going to, this will specify that we're going to add a device to that static group. And then we've got the ID. We can specify the ID of the device we want to add. So we recreate that as a string, and then we pass that to the httpBody on the request. And likely, also, if you want to remove an item, it's the same XML, apart from instead of using mobile device additions, we can use mobile device deletions, and again, specify the ID. So it's very, very similar. So we create the XML, pass it to the body, create our session as normal, and then we can handle the error, look for the status code of 201, and if that's looking good, we know that command has executed, and hopefully that group has been updated. Okay. So that's some examples of the classic API. Then to follow on, we've got the Jamf Pro API. So these are the new APIs that have been added over the last couple of years. So this is the more modern way of handling the APIs with Jamf Pro. So there's still a lot of APIs that are only available on the classic, but anything new that Jamf adds tends to go under the Jamf Pro APIs. And there are some subtle differences in the way it's handled. The main difference is authentication. So with the classic API, we use a base 64 of your name and passwords to authenticate to that API. With Jamf Pro, we actually use a token, which we'll look at. And also the other additional change is our payloads that we upload can be XML or JSON, whereas the classic API was limited to XML. So the endpoint is slightly different. So with the classic, we was hitting JSS resource. So with the Jamf Pro API, we're going to use /API. So that's the endpoint. And then for the authentication, we want to create, or we want to get access to a token. But we still have the same accounts we're going to create. So you can still use the same account initially in Jamf Pro, assign the same permissions you need. So that's going to be as before. But we need to get this token. So the APIs use what's called a bearer token, and these tokens are valid for 30 minutes. So once you get one, you can use these tokens to authenticate to any of the Jamf Pro APIs, and as long as that token is valid, you can authenticate. However, you can also renew the token. So long as that token is still alive, you can also use that first token to then generate a second token that has got a refresh 30 minutes validity period. So it just means that if you're running long-running tasks where you're using lots of API calls, you don't need to keep re-authenticating. You can keep hold of your token and use that to authenticate. So to get the token, this is the endpoint. So it's /v1 auth token, and we can use a post method for this. And this should be familiar. So to get the token, we still use base64 authorization. So we're still going to create a base64 for our username and password. We're going to create the URL. So in this case, it's going to be /API /v1 auth token. So we create the URL for that. And then we're going to create the request. So we're going to create a new URL request. In this case, the method is going to be post. The authorization for this one-time call is going to be basic, and we're going to pass in the base64. And we are going to get the a data object back, because we're going to get something back for that token. So we could use JSON or XML, but I'm choosing to use JSON to handle what we get back from the Jamf Pro instance. So what we get back is on the right-hand side. We get two items back. We get the token, and we get an expiry date for that token. So the structure we're going to create is very simple. It's just a basic structure. It's got two properties, one for the token and one for the expiry date, both are strings. And then we can create a session, start it off, check for the error, check for the response codes, the status code back, and then assuming that's all okay, we can unwrap the data and decode it back to our Jamf Pro authentication structure. And then from there, we can get access to the token and the expiry date if required. Okay, so now we've got this 30-minute token we can now use going forwards. Okay, so the only time we use base64 with the Jamf Pro APIs is either to get the token initially, or if you need to renew it, you can go to the v1 auth keep alive endpoint, and then you can just pass in the token that's still alive, and you get a new token back. So when you're using the token, the HTTP header is slightly different. So we still use the authorization header, but instead of using basic and the base64, we use the bearer keyword, and we pass in the token we got generated. So in this case now, we should get a new token back. So let's see this in action. So the response codes are slightly more sophisticated than the classic one. So we've got a few more response codes. So we've still got the 200, 201, but there's a few more, which are a bit more interesting. You get a bit more feedback about what goes wrong if something goes wrong. So the example I'm going to use is the pre-stage example. So in this case, we're going to, first of all, get a list of devices in a specific pre-stage, and then update that pre-stage. And this will highlight another subtle difference between the classic API and the Jamf Pro API. So the endpoint we want to hit is v2 computer-prestage's ID scope. So we create our URL as normal, and you specify the ID of the pre-stage we're interested in. So in this case, it's going to be ID2. Okay, so we create our URL. We create a request, so we're going to use get. So the authorization is now using the bearer token. So this is where we're going to use that token going forwards. And we want to use JSON for the data that comes back. So that's our request. We're going to create a structure to handle what comes back. So on the right-hand side, we've got the raw JSON. So it's pretty straightforward, hopefully by now. So you've got like an array of assignments. So that represents the serial number of the computer, the assignment date, and the user. But notice the version lock. So one of the things that the Jamf Pro APIs incorporate is this optimistic lock system. So the idea is you don't want a situation where you're going to have concurrent calls making changes to the same API endpoints. Because the last thing you want, as in this example, is maybe two applications trying to modify the pre-stage at the same time. So what you can do is you can query an object, in this case our pre-stage, and you get a version lock number. And then when you make a change to that pre-stage, you have to supply the version lock back to Jamf. So it then knows how to handle and in what order to handle any kind of queries to that specific pre-stage. Okay, so the version lock is quite important. Without the version lock, you can't make any changes. So we're now going to capture that along with the data from that pre-stage. So we've got our structure. We create our session as normal, and we do our decoding. Okay. So that's got the pre-stage back. So to make a change to it, we're going to add a computer to that pre-stage. So we create our URL. So it's the same URL. Okay. We're going to create the request. So we're going to use post for the method. We can use the bearer token for the authorization. We can accept the JSON back if we get any data back, and also we need to upload a JSON payload to specify how we want to modify that particular pre-stage. So when we look at the classic API example with the static group, we use XML. We could use XML here, but this is just an example of using JSON. So we need to create a JSON payload to tell it how to modify that pre-stage. So in this case, it's going to contain two items. We've got an attribute called serial number, which is going to have an array of serial numbers you want to add to that pre-stage. And you've got the version lock you was given. So you're going to pass the version lock back as well. So we're just using standard Swift collection type here to handle that. So we're going to create basically a dictionary, and we've also got the version lock, which is a string as well. Okay. So this is created a native Swift type with the data we want, but we now have to convert that to JSON. So we've got a command called JSON serialization. So this would basically take a Swift type and try and convert it to JSON for you. So again, we're using the try question mark. So this is going to use the optional version. So it's going to try and do this conversion. If it can't convert that JSON object we created to raw JSON, it will fail and we get nil back. Okay, so hopefully it'll work, and then we can pass that JSON data to the httpBody. So just a different example. Instead of using XML, we've used JSON for this. And obviously, the first line where we built the JSON up, you can make it dynamic. You could dynamically populate the serial numbers on the fly, etc. Okay. And then we create our session. We handle the error. We handle the response codes. And assuming you get the correct response code back, then all should be good. Okay, so just an example of using kind of version locks with these APIs. Now to wrap up, so with WWDC this year, with iOS 15 and macOS 12, Apple have made some nice changes to the asynchronous APIs, and one of the main changes is they basically changed the way you handle these asynchronous calls to make your code a lot cleaner and to make it a lot easier to read. So there's a URL to the actual session on this, but just to give you an example of what it's going to look like, if you take the example we've been using, so here we've got a session. So the first line creates the session. The bottom line starts that session off, so it calls resume. But in the middle, we have the closure, which is what handles the results back when that task is executed, and we don't know when it's going to run. So it's a bit all over the place. Now, line 1 is the setup. The last line is the execution, and then the middle piece is the result, basically. And if you've got multiple versions of these for your application, it can get a bit unwieldy and hard to read. So with these new kind of asynchronous API calls, they're going to do away with the closures. So instead of having these closures, you're going to be able to have your code in a linear fashion that you're used to, basically kind of top down. So we've got this new try await command. So try await will try and run that URLSession. So we still create a standard session and pass it a request, but we don't pass it a completion handler. Instead, it's going to return 2 values back to data and response that we've created there. But it's going to do it asynchronously. Okay, so it's going to call that session, it's going to execute it, and then we don't know when, but at some point it will then return the values back, and then the code will carry on, and then we've got our decoder and we can handle the data. So it just makes it a bit more linear. Okay, so it's still asynchronous, so it's not going to block your application, but it just means when you come to read this now, it's so obvious now what the order is. We execute the session, and then when we get data back, we then handle it in that order. Okay. So this is coming for Monterey and iOS 15. As of the time when I did this recording, these new APIs, this new way of doing things, only works on macOS Monterey and iOS 15. It's not backwards compatible. Okay, so something to be aware of. And finally, I'll say dataJAR. Now, where do we use this? So we use Swift a lot. We've really embraced it. So any native app we build is done in Swift. So we've got a number of apps we use either internally or for our client base. So the screenshot on the slide is an example of our management app we give to our customers. And it's got one of the things it's got is like a dashboard to give you them an overview of their state inside Jamf. So this is using all the standard API calls we looked at, but you then using kind of a native Swift application to kind of display it in a nice format. All our command line tools are written in Swift. So we have some agents we deploy that we've written internally. They're done in Swift. The only exception are scripts. So you can run Swift in the same way you can run Python scripts or shell scripts. The problem is though, macOS doesn't run them natively. To run Swift scripts like a Python script, you either need Xcode installed or the Xcode command line tools. So chances are most of our clients won't have that installed. So if we're deploying any scripts client side, they tend to still be Python or shell scripts. But if I want to do a quick script for my machine, which is a dev machine, I've got Xcode on, so I probably still use Swift myself. Okay, so we do use it heavily at dataJAR. It's a great language, really good language. So finally, we've got a GitHub repo set up. So there's a QR code for it, etc. So if you go there, I've got a copy of the slide deck, and I've also dropped in some example Xcode playgrounds with all the examples in the slide deck. So all you've got to do is go in there and just substitute in your URL, your authentication details, name and passcode, and then you can also then try them against your own settings. So thank you for listening, and have fun.